Haven't used this thing in a while. Where does it show up? Keycaster. Do y'all see it? I don't see it. Stop casting is A. It's an odd shortcut, isn't it? Maybe we needed a new one. Anyone see anything? Nah. Probably find it later. Oh well. Array type. There's an array type. Inner type. Element. Type. DI type. Size in bits. Layout. Size bits. Layout.align bits. Subscripts. I don't know what that means. Let's leave it empty. Layout. K1 types get PT layout element. PT. This thing should not take a pointer. And now I gotta fix that probably in like 100 places. Originally I thought physical type was gonna be bigger, but it ended up being 8 bytes, so it fits in a register. So taking it by pointer everywhere is silly. You can see we usually have a value anyway. All right, any more? Nope. One sec, let me see if I can pull up the YouTube dashboard just to make sure no one's here. If you're here, let me know. All right, it says I'm live now. How do I see it? Take me to my dashboard, please. Go live. There's a button to go live, which is interesting because I am live, I think. How do I get to the live dashboard, friends? Sorry. Hello. Hi. I'm just looking for the YouTube dashboard right now. I can't find it. Content, live, view in live control room. Yeah. All right, now I'm here. Cool. That's all I wanted. Hey, there's two of you. Welcome. Sorry to make you look at a black screen. We're back. Yeah, I'm not really in a teaching mood tonight, but what I'm doing, see, I have a CodeGen LLVM and a CodeGen LLVM new file, and I'm rewriting the LLVM CodeGen part of the compiler to work off of, when I wrote CodeGen LLVM, I did not have my own bytecode, so it works directly off the tree. So like lowering things into basic blocks and compiling types to their like layouts and stuff happens here, and it also now happens in my own bytecode. So these things like do completely duplicate work. Now that I have this, the idea is to CodeGen LLVM off of my bytecode, right? Off my like physical types I already have. So it's just sort of like a bit of a rewrite exercise. But you know, what's fun is we have 4,700 lines in CodeGen LLVM, and so it's like a race to see how short new ends up being. I copied the whole thing in, so the fact that it's big now doesn't really mean anything. But one of the most meaningful things that it does is generate debug info, which is what this DI stuff is. So a lot of the lines of code are coming from this, like, you know, really verbose construction of these like debug dwarf. Really, it's just like dwarf info, so that the debugger works for your language, which is pretty cool. Anyway, that's it. I'm just gonna kind of crank here, so I might pull up the old file to consult what it does every once in a while, but mostly I'm just gonna be cranking through. The rewrite or the port. This is called debug type. This is the wrong size, and this is good. And this wants to be indirected, so this is going to be self.mem.push type. And now we have a DI type. And we need a layout, which we have. So I find myself increasingly often writing code backwards, where, let me move my mic a little bit, where I will write the last line of the function. Often it's creating something, and then think about what needs to happen, you know, bottom up. Just do only the necessary work. It doesn't work all the time, definitely not all the time, but sometimes it's exactly how you want to write something. Write it from the last line of code up. That, yeah. What? Push handle. Okay. And your as type. Okay. And how long have you been working on this? Sorry, I'm not very good at remembering to read chat. I've been working on this for about 3.5 years, but only pretty consistently and heavily for like 2. But most of the time, really, should count towards like learning, not building, if that makes sense, because I knew nothing about. I mean, I had a pretty good background in programming and languages, but had never built a compiler. So that's not to say it's 3.5 years of work. It's definitely 3.5 years of study, right? And then learning. But yeah, it's been very wayward. I've had to tear it down and redo it a lot of times as I've learned. But same code base the whole time, and mostly working all along, just replacing one bit at a time, sort of. For opaque types, which we currently only use to represent our tagged unions either in the source. We generate a 2-field struct to trick LLVM. Field 1 is a synthetic integer wide enough to force the alignment of the struct, and field 2 is an array of bytes ensuring no padding at all, large enough to get the whole thing to be exactly size. This is mostly what Clang does for unions, and probably what I'll also do for unions to have them. Did I have any resources for learning compiler stuff? I had studied a little bit in college, and so for theory, there's a book called Types in Programming Languages by Benjamin Pierce. Where is it? Yeah. So this book is awesome, especially if you're interested in like type theory, not so much implementation and like building something concrete, but he does have implementations at the end of every chapter of a compiler, but it's very academic. It's like it's all in OCaml, but TAPL and his other software foundations books are really, really good. So fun. So this one goes into like, he builds he builds a Java and OO language, like from theory all the way up, and proves some properties about it. It's pretty nice. But then there's the Thorsten Ball book, Building a Compiler in Go, right? I think that one's really good. But yeah, you really just want to start writing one. Just pick what you want to compile, whether it's your own language that you want to make up, or maybe you just decide you want to compile Python or run Python or something, and just start trying to write it. Is really the best way to do it. And then you'll have questions. And then when you go to research, you'll be researching from a place of like proper motivation and understanding of what the problem is. And it'll be like far richer when you actually like encounter materials. Hope that helps. So like, all this layout stuff, I mean, I know a good bit now, but it's been a really slow journey. And, the first version of the backend I did, really probably made like no sense. Big picture to someone who really knows this stuff. But you kind of have to get through your infancy, I guess, in any field. So yeah, if you don't go through that part where you're doing the thing even though you don't know what you're doing, you probably never get to the point where you do know what you're doing. But they're really hard, I think. Compilers, they can get really nasty really quick. So it's the kind of thing where you may end up needing to start over a couple times. I false started on this project. I couldn't really manage to compile the code the way I wanted to or type check it. But I eventually got there. Oh, to make a CPython, like an ahead of time Python compiler? Yeah, I would use C++. Use C or C++, or I mean, Rust is a great choice. Yeah, Zig is great. I would maybe not pick Rust unless you're really experienced, because it will get in your way a good bit. It'll make you write code a certain way, and that's great if you want to get better at Rust, and it's like a fantastic skill, but it can be a little bit it can definitely be tedious to fight the borrow checker. Like you'll see, I have this, like from a Rust perspective, it's an absolute abomination. It's just like a manually managed heap of my own where I can just put whatever I want, and I just don't worry about the borrow checker because I'm never going to free this. And I only put types in there that don't have drop glue. So like no dynamic, just like not run into a lot of trouble with Rust running destructors, but yeah, if you just use something that's less in your way, you don't have to go to such lengths to just like write the code you want to write. That's really cool that you're implementing the calling convention yourself and generating assembly. That's definitely the best way to learn. So my interest with this project was the front end of the compiler, just based on my career in building applications. Like I wanted the back end to be solved for me. So LLVM was like the perfect abstraction. Now I've gotten to the point where I am a lot more interested in some backend stuff, and so I would definitely try my hand at doing the assembly lowering myself soon. But yeah, that's really cool. I mean, that's going to be such a good project. All right, so let's consult the old file for this, where I make this, I make up this type that, I do it for enums. And I call it the physical type correct align. So this guy, aligner type, padding bytes, padding, and then this. So, and then we have our, this is going to be process. I wonder if I should do a video on the memory stuff. I just feel like I'm going to get like canceled and roasted by Rust people for my horribly unrusty arena, but it makes Rust fun and productive for me in this project at least. What IDE are you using? This is NeoVim. Good old NeoVim. Ultimately, we need to produce a CG type. Yeah, we don't even have, let's invent a new one. So we may not end up having this. we may not end up having this. Let's just do our opaque, CG opaque type, and see how it goes. I wish people fought less. Yeah, well, I mean, I think it's good that people form strong opinions about how to program better or how programming could be better. But yeah, fighting certainly doesn't help. Make sure that the mic's not too loud. Is that more or lower? Yeah. Okay. Saw the video on compile time execution. I've been trying to understand how to implement them. Well, I would start with, man, let me just try and fix this volume. I would start by trying to execute. Well, how do you execute, like, if the expression is just the literal 3? How do you execute that? And then, okay, one step forward if it's a binary op, right? If it's 3 plus 4. And then, you know, the next step is if it's a block of code and there's a statement, right? Like a let statement or a variable. It's like, okay, well, I need to store the variable somewhere. And then you'll slowly build up. You'll have a little environment of like, okay, X points to 4 and, you know, what the variables point to. And then you will slowly rediscover like a virtual machine, a computer, right? You'll start implementing a tiny computer as you try and interpret more and more expression types, and then just let it grow from there is what I would do. And then once you feel like you kind of get your footing, you can read about different types of interpreters, but a stack-based interpreter rather than like a register-based one is probably the easiest to implement. Yeah, my compile, when you execute compile time code, like the whole compile waits for that code to finish because that code might like generate a value that is actually used by the rest of the compilation. So it's not async. So yeah, the compile can wait for types that are being generated. You can return a string from compile time execution and then that code gets compiled immediately. So it's the point is to like be able to trivially generate like a, I don't know, imagine like a 2JSON function for any type. You can do that by just like returning the code for the 2JSON function. I have a test that does this. This test meta file. So, you know, here we 2JSON on true, and here we 2JSON on a anonymous struct. And those are calls to the same function that just takes a T. And this is just boilerplate creating a string and returning it. And really everything comes down to this write JSON function, which takes any type and then a writer. And then runs this code at compile time. And this code ultimately returns a string into this string builder, right? So it's just a string builder, and then write JSON from schema is kind of the magic. He takes a type ID. So it's just a normal function, and this function can run at runtime, but and he just builds the code that is like, okay, if it's a struct, then, you know, crack open a JSON object, and then for each field, you know, generate its name and then its value and then recurse. So this function, it's not terribly readable right now. And the syntax highlighting is horrible, but even though it's kind of hard to read, there's nothing. It's the simplest metaprogramming code I've ever read to do this, and I've read a lot of different versions of it, and so this is the result. So it actually produces this string. It just works. So in like 40 lines, you have like what SerDes doing for you in Rust, which is pretty cool. What is the star in let? Oh, that's a great question. So it means that you get a pointer. So string builder new returns a string builder, like by value. But we need, so in order to have something we can mutate, you need a reference. So let star does. What we actually get here is a star mute string builder, even though this returns a string builder. So it's a way of saying, like, both of these compile just fine, but without the star, I get just what the right hand side is. With the star, I now get a place on the stack that holds what the right hand side is. So it's the way, more advanced way to say it is the way to talk about stack memory. Yeah, it's the way to talk about stack memory in the language. In C, you would do this. You would say let code. Let's do like let code v for value, and then you would say let code equals address of code, and then from then on it'd be the same. So it's like the address of, it does the address of for you. I'm not like horribly in love with it, but I do think it's kind of clean. And it avoids having an address of operator, which I think is a very confusing operator, even though it's really powerful, and I totally understand why C has it. And I like appreciate it much more now, having done it a few different ways. But yeah, let star means pointer, or let star means reference, let reference. Or like could give me a place. Yeah, that's a good point. I just like, I cannot express to you how big this is now. Like, once I make it, you like the star? You like let star? Nice. Yeah, I think you can get used to it. It works. What I need to do is capture it this large and then like have like a zoomed out window. It's just too big. Okay. So this wants to be a struct, and we're gonna call it like the aligned struct repr, and this is gonna be an LLVM struct type. And we might want to know the layout. It's probably the most important thing, and we probably don't need the physical type. I'll just put it on because I'm putting it on all the others. And that'll be fine. We probably won't use this. I don't know if we use the reference. Okay. So now it's not that, it's the layout of the opaque. And the aligner type. What next? I think we have a PT aligned struct repr. let's just name it align struct representation. Then our layout has been given to us. So what this type, this is for tagged unions, basically, where we actually don't know what's inside here. Like we have to treat it as a black box of bytes, but that black box of bytes has a particular alignment because like one of the variants might have a float, right? Like, or might have a double, and so it's like needs to be 64-bit aligned, but we don't know if it's the double variant because it might be like the none variant. Like if you had like enum A, B, C, D double, right? Then like the whole black box, like this entire box needs 8 bytes for the tag, right? And then it needs an aligned double. So basically a way to trick LLVM into giving you a type that will never lose any information but also is aligned correctly is to hand it a struct, in this case, where the first thing in the struct would be I64 so that it'll be aligned correctly, and then if there was any more space, just bytes times however big the thing needs to be. So that's the best way I've found to like represent a union in LLVM. There's also the idea of like the class. So if like the union, my unions always have a tag, so this isn't true, but if the union is all floats, then you would want to make sure to represent it that way. Yeah. Well, no, I just don't think you would ever want a union to go into like a floating point register. I don't know. I would need to check on what Clang does. But this is good enough for now. And I think that's all my types. I need to do enum variant, which I guess I can just check what I do for enums in my old backend. So for enums, that's what we do, and for a variant, right, we just do we just do the whole enum. But this backend is not even going to need knowledge of those because it doesn't have to lower things. Like, oh, it does have to deal with static types though. Physical type record does not implement copy. It's 40 bytes. Okay. And so if I don't dereference it, then we have a Rust problem because of the layout. So we need to make a copy of the layout up here. And use it down here. But there's still another borrow. And this is why I don't super recommend Rust. Okay. Because the thing I'm pointing to here, its lifetime is like the whole, like it's never going away. This pointer will hold until we are done compiling, but we still have to do this. The colored underlines is just, well, for my language, how do I get the colored underlines, any of them? For my language or just for Rust? Rust. You install Rust Analyzer, and you can Google how to set up Rust and NeoVim. There's actually a plugin for it, but you don't need the plugin. You just need to install Rust Analyzer and then start Rust Analyzer when you open a Rust file. Here's my NeoVim config. We can go to Rust. So if you're using NeoVim 11, then you can just put them here under LSP in your config. And then here are my Rust Analyzer settings. And that's all you need to do. You don't need this. This is a feature of my project. But yeah, just a quick Google is going to be more helpful than what I can dig up. I think the underlines are like a default thing, if I'm not mistaken. I can search for diagnostics, but I really don't like the words on my screen. And even these are too noisy for me. Here, I turn off virtual text. And apparently I turn off underline, but it's not off. So I've never tried an HHKB. You want to send me one? I'd love to. One day. Well, thank you all for hanging out. This is fun. All right, so I think we implemented CodeGen type. Yeah, it's a little smaller now, but I do agree. Nice. Yeah, I like the sound of them, and I like the idea for sure. I kind of use the layout because I have control where caps lock is, like the happy hacking layout. All right. I think that if we get asked to CodeGen enum variant, I'm going to say panic, and I'm going to say who is asking, because I want to see a stack trace and I want to know what CodeGen leads us there. So that'll be fine. And I think I'm going to go back to CodeGen function signature. What sort of language am I making? It's it's a good question. Check out the README of the repo, which I think is in the description. So for the joy of programming, C, K1 is like C with type classes, full compile time execution, ADTs, capturing lambdas, pattern matching, control over memory management, metaprogramming, and generics. Plus other things. Everything I want. All the things I like. But sometimes you think you like something and then you implement it and you realize that someone else is smarter than you and then you change it. But that's been a lot of fun as well. I think that maybe I had declare LVM function. Yeah, I fixed the name of this function. The metaprogramming in K1 works by running code at compile time that returns strings, and those strings are source code that gets compiled. And also through like a really powerful, like through compile time reflection, where for any type you can get
a value that represents everything you want to know about that type, and then just like program against those values, like normal values. So for example, you can just like, if you have a struct, you can just say, give me the schema for the struct, and then just do stuff with its fields, like generate a pretty printer, or turn it to JSON, or write it to disk, or generate open API, Swagger, YAML for it. I have a demo in the README of the repo actually that is a metaprogramming demo, but I'll probably make a video soon on the bitfields demo as well, because I think it's a good example. The return type is a physical type. You want to be a CG type, and that is reasonable. And then how do I decide if it's SRET? Because I get the ABI mapping from the return type. What do you do with the return type? Oh, interesting. Get ABI. It's not always a param, it could be the return type. Get ABI mapping for type. And then we'll just call it PT. Okay. So basically we just never really need to know what type it is. Cool. Okay. So make LVM. This is now param types, return type, ABI mode. Param types, return type, ABI mode of the function. Typed function. Does it have an ABI mode? Where does that live? Lives on the function's type. Okay. Have I grabbed that yet? I have a function. I have a typed function, but I don't have a function type. So let's grab the function type. We'll call it the K1 type. Function type ID, that we should have. Oh, wait, but we've code-genned it actually. Right, we don't need one. Code-gen function. Does it have... Why doesn't it have anything on it? Oh. Oh, not code-gen function. Going crazy. We have a typed function. Okay, I didn't compile the bytecode yet. Codegen. How did I come up with the name K1? My name starts with a K and it's my first programming language. So it's more of a code name for the project than a real name for the language.
This thing has the params that I want and the return type that I want. No, it doesn't have the return type, but it should. Compiled unit. What I'm trying to figure out is if my bytecode should store the ABI mode of the function. But maybe not, because it's just duplicative. I do think it should store the return type though. How do I get the return type usually? Okay, so for a call, that's fine. I am using Inkwell to work with LLVM. Inkwell, it's a nice wrapper around LLVM sys. When I was first getting started, it was kind of a godsend because I don't think I knew enough of the domain to have worked well with LLVM sys directly. Today, I would totally be comfortable just using LLVM sys, but Inkwell is really nice because LLVM is pretty high level, so you can really you can know very little about what goes on in the back end and like get really far. So yeah, I do recommend it. We can look like the stuff I'm doing right now in the Cogen file. Here, like this LLVM module, this is an Inkwell type. This is the Inkwell LLVM module. So like it has add function, right? This adds a function to the LLVM module. It wants a name, it wants a function type, and it wants a linkage. I'm going to get the ABI mode off of the place that I already have it. So we're pulling some stuff from our compiled bytecode function, and we're pulling with like lowered types, and then we're pulling some stuff from the original type checked function. I think that's okay. And this is going to be the typed function type ID, which hopefully we haven't accessed yet. No. And here is params. That's fine. I don't mind that in the least. Bytecode function params. Please be the right type. A slice of physical type, it's close. Be self K1 bytecode mem get in. Return type bytecode fun dot return type. It really should have a return type on it. I'm going to look into this. So we have the X per rec kind. If a compiled expression, the return type. And I think we do use this finalize unit.
the return physical type of a top level expert, and then here's a function and we don't put it in. So yeah. And then where all is the expert kind used? Right. We check if there is one. I would rather just like, right, we know it's an expert anyway, and that's like the only place I use it. All right, so we're gonna refactor something unrelated. We are now going to say that this is the return type of the unit, whether it's a function or an expression. It is no longer optional. And in this case, that's just the return type, and that's what it is. And then if you want to know what kind of unit it is, then look somewhere else. Ah, I see. So some expressions don't return. Well, shoot. All right. It still needs to be optional, but not for the reason it was optional before. So we'll say none means void or divergent. Okay. And, oh, our comment's in the wrong place. We want to comment this here. Ah. Uh-oh. That was a big old freeze. I don't know what just happened. But we lost our highlighting, and we also lost our LSP. All right. Do we program old school, or do we restart it? Okay, yeah, it's just hosed. Let's just close it. This buffer's fine. Unit.return type. Yeah, okay. So now that's much better. Okay. Okay. And then if there's no okay. It could return void. So maybe I'll revise this signature here. Yeah. The modern route and say everything has a return type. Unit or never. Yep. That's right. And that is how the language works. Everything does have a return type, but the problem with this type here is this is a physical type, and I don't have void. I don't have void here. So I don't have anything to put. But maybe I should just add void to physical type. It would actually solve. Now I do have it as an instruction kind. So this is really my value type. So really maybe functions should return an inst kind. And it's not so much an instruction kind, is it? It's really like value, but it's not a value. So that could be the answer though.
Now my problem is I want a version of this for now. So I'm gonna do something I really hate, but it's fine because I'm not gonna keep it. What it is I don't have enough mental clarity over what the right thing to do here is to know, but if I don't move forward, I won't get it. So I'm just gonna do this version where if it's none, then I'll do my CG void type. I do have this, and apparently it has a debug type and a void type. That's fine. I definitely know my story around void and never in the language, but when it gets down to like my bytecode and then this LLVM, things get a little sketchy. But for now this will work, and if it's a case where I might have a void, I'll just call this version of the function. I don't know what is there a void? Oh, it has unions. That's pretty cool for later. It has lexical blocks too. What in the world do you use for void? For a debug type, I wonder what I used. Debug information entries for C functions should not have an attribute for the return. Well, this is what I was using for. It's not really never at all, though. It's not. I think that that's fine, though. We'll do something like this for void. But we're going to call it. All right, so the thing is I don't even have void in my language, but when a function returns a big struct, it actually returns it in the first parameter and the function returns a void. So I do need the idea of void of like LLVM void at least. For this, when we make an LLVM function type, well, I guess that's not true because here, well, it could be never. It could be never. And I don't have never in here, so we'll stay the course. What language is this? This is Rust that I'm programming in here. And the language we're making in Rust is just a language that I made up called K1. Right. So this takes a physical type. All right. The more I do this, the more I really want to add void here, a zero size type here. What would be the mapping? It's just what it is. So we would just call it void. Yeah. I'm just gonna match. Ooh. Or we could take a CG type. That might be better. Let's do this just quickly here. CG type void. Well, special case void. ABI param mapping. This will be what I use, and then for anything else. Oh, I would need to unwrap it. All right, let's match return type. It's fine, it's fine, it's fine. Okay. Return map type. Ah, yeah. No. We run into it again because it could be void. All right. I don't care. I don't care yet. Since I think I'm going to add void as a physical type and this will all be nicer, we're gonna do this for now. So the map, we're supposed to return an LLVM type, right? So this is gonna be self CTX, void type, easy. As, oh, void is not a basic. We could return an option. So the real scenario where we'd get here is a function that returns never. I do want it to return void, so this isn't good enough. But I don't want to open it up to any type at all. So far this is called, it's called here, and then, yeah, we want basic types. What are the functions final params used for? Right. Oh, into. All right. Yeah, I think we just don't call this. When we don't have a return type. So the return map type. What is it used for? Right, we have a return. Okay, one type. It's only, yeah, and we already have the void case. So that's fine. I can just use option to represent the void case, I think. So it'll just, we'll just have this like be a mapped option. And you'll get down here. If it's SRET, No, actually, it's going to be void. No, if it's sret. Yeah, then that actually would be. Then you have one. Oh, I see. Let sum return map type else, and then this would be like a panic, but we could return. Do we have a span? Span debug current span? Sure. Just be like sret, but no return mapped type. And then it better be a pointer, and then we're gonna push it. And then down here, we're just gonna match turn mapped type. And if it's none, then we're doing the void thing. If it's some, make a function type from that. And it's not return K1 type, it's return CG type. And this is return CG type. What a mess. Woo! Let's not do that. Let's do, we're still in declare LVM function. And I'll probably need to wrap this up in the next 5 minutes. Thanks for hanging out though. Nice to meet you all. All right, let's just grab that. What? No. Okay. And then what are we doing in here? All right, another pass for params. So, and then all the magic. Gosh, this is just like the wrapper function. Like this is actually, this is the housekeeping function around make LVM function type, which is like the core logic function. This one, I want to get to the core loop of this one. Right, and that's where we just were. Yeah, I think it's good. Okay. None of this changes. Okay, I think that works. Can I call you dad? Yes, you may. I am a dad, actually.
So I'm used to it. What's next? Oh my gosh. The rich repr layout. I thought I did this. Oh, I think I have this function twice. Oh, the layout. That's what you need. No, I did the rich type too. Whatever. This is definitely two places. Ha! I can search for them. Gotcha. So this one doesn't need to exist for now. Let's just like make a mark. Like no, this need to exist by the end. Debug type. That's actually the whole point of you. Oh, we didn't put a debug type on the opaque. I need to make that. That's gonna be a pain. This one's actually, oh, all right. This is where I'm screwed because I've lost information with this. So it's gonna be much better to go back to unions. For now, let's fake one. So I don't know. This is gonna be a big no commit. Like, we need, once we go back to, once we introduce union as a physical aggregate instead of using opaque here, we'll be able to generate a good debug type for our enums tagged unions. But for now, we'll generate a garbage one. And this is going to be like di type equals stuff. Debug builder, create basic type. To do opaque size and bits. Well, that one I have. Size bits is U64. Encoding, I don't know. Flags, I don't know. Unwrap that, sure. Dot like as type. My gosh. There. Okay. No, yeah, there's not going to be one. This will be cg type.type ID. What would be the way to print that? Oh, to grab the physical type off of it? Yeah, that might be good. We would eventually put physical type here. Yeah. PT? I think that's fair. Ref CG type. Maybe that's what I should take in here. If all you need is a physical type, though, I can do that. Okay. I'm sold. self k1 types pt to string pt there fixed pt and layout rich layout shit. Struct an integer self dot k1 types pt layout pt. It's probably not ideal to have to do that here. That's why maybe we should take the other type in, but that's fine. This one's a pt too. But that one's a CG type because I haven't changed it yet though. What does it really need? It needs the alignment. All right, well, I gotta go. This is gonna be a grind. We got like 4,800 lines to rewrite, but this is not too far from being able to start on the actual blocks, which should go really fast. Thank you all for hanging out. See you next time.